In this video, we are going to discuss about the diode and the thermistor compensation technique. After completion of this topic, the students will be able to interpret various applications of diode and they can able to classify the various configuration and biasing techniques of BJT. So in diode and thermistor compensation technique, here we are using this compensation technique in order to make the stability factor as stable, that is we have to fix the Q point as stable. So here we are using some of the temperature sensitive devices which is we are calling as diodes, transistor, thermistors to compensate this voltage and the current to maintain this Q point as stable. For diode compensation technique, first diode in the emitter circuit we are placing, so that the below diagram it shows that the voltage divider bias with the bias compensation technique. Here we are giving on separate voltage supply, so that this diode will be operating in the forward direction. If this diode is used in the circuit which we are using as the same material and the type or same means, then this voltage across this diode will be having the same temperature coefficient as that of the base to the emitter voltage. So whenever there is a change in the base emitter voltage, then there will be change in the dou VBE, so that is change in the temperature. Then VD changes, that is diode voltage changes by VD, so that this change in this voltage tends to cancel each other, so that we are applying KVL, we will be getting that VT is equal to IB RB plus VBE plus IB plus IC into RE minus VDE. So in this diagram we can see that the diode is placed in the emitter terminal and also separate voltage is given, so that both the VDD voltage, that is if there is an increase in the voltage, they both cancel each other. So you can see it in the diagram itself. Then temperature compensation technique, we are considering the leakage current. So in the case of the leakage current, if that is emitter is open circuit means, then we can see that SIC is equal to beta into IB plus the leakage current, that is collector current will be containing the minority current as well as the majority current. So minority current is nothing but the leakage current, and the maximum current is the original current. So I can write it as beta into IB plus 1 plus beta into ICO. Therefore from this equation we can write it that is IB is equal to IC by beta plus 1 plus beta into ICO divided by beta. Here we can substitute the value of the IB in the above equation, so we get the value of VT value. So on the derivation of this part, we will be getting finally the IC value is equal to beta into VT minus VBE minus VD plus RB plus RE into 1 plus beta of 1CO divided by RB plus 1 plus beta into RE. And here we are considering the diode in the voltage divider circuit. So since we are considering the voltage divider circuit, here we will be connecting the diode in the series connections. So this resistance R2 will be in the voltage circuit as in a forward bias direction. For this voltage divider bias, we can see that is I is equal to VB minus VBE by RE, so that we will be getting the IC value is equal to, that is we know that IC is approximately equal to IB. Since only 2% of the base current flows to the circuit, we can say that collector current will be approximately equal to emitter current. So whenever there is a change in the base emitter voltage, there will be change in the temperature. So once again it's cancel each other. So we can write this equation as VB is equal to VR2 plus VD. And in the case of this compensation technique, here we are taking the germanium transistor which is changing in ICO with the temperature, which that is playing a very vital role in the case of the collector current stability. And also this diode is kept at the reverse bias condition, so only this leakage current flows along the circuits, and also this output current increases, and therefore this minority current also increases. And in the case of the diode in the voltage divider circuit, you can see that you are placing the diode in this region, and also this value we can write in the case of the germanium transistor, that is I is equal to VCC minus VB by R1. So we know that for germanium it is VBE is equal to 0.3. So you can substitute this one, this is very small, so that we can neglect this changes which is happening in this temperature. So we write this equation as I is equal to VCC by R1, which we place it as constant. And we know the equation, that is IC is equal to beta into IB plus 1 plus beta into ICO. So from this we can apply the equation and find out the collector current. Whenever there is a change or increase in the temperature, the both of this diode increase in the current and the increase in the leakage current will be cancelled each other. And the quiz questions on the diode compensation techniques. Compensation techniques refers to the use of diodes, capacitors, resistors or transistors. Thank you.